Hi, in this video, we will try to finish example C together. Here is our problem. Let D be the reason bounded by the curve YE, the square root of X, the line XE4 and the X-axis. The problem is find the volume of the solid of revolution generated by revolving the region D about the line XE5. First, we will scatter region D. You can see is the XY coordinate system. We scatter curve Y is the square root of X. And we scatter line XE4. This is a vertical line. And here the X-axis. So our solid are So our region is a region bounded by this curve. That means this region. And now we sketch the axis of revolution, the vertical line XE5. We will use the red color to sketch this line. I want to sketch a line. Right here, please add an arrow here to indicate that this is the axis of revolution. Now, by revolving this region about this line, the line XE5, we obtain a solid of revolution. And you can see that our solid revolution is partially hollow inside. So when you cut our solid of revolution perpendicular to the y-axis, you will obtain a cross section, which is of shape like a washer. So we will use the washer method here to find the volume of the solid of revolution. Right here, washer method. But notice that our axis of revolution here is parallel to the y-axis, not the x-axis. So when you cut our solid of revolution perpendicular to the axis of revolution, that means you cut perpendicular to the y-axis, not the x-axis. So the formula for the volume of the solid of revolution here is the definite integral from C to D of pi R big squared minus R small squared. But the differential here is not dx, it is dy. And our radiuses of revolution are dependent on y. Well, the BR is the outer radius of revolution, or the bigger radius of revolution. As small r here is the inner or the smaller radius of revolution. Now we will sketch the big R and the small r. The outer radius of revolution is the distance from the axis of revolution, you can see, to the outer boundary. That means the boundary is that the farther the axis of revolution than the other one. Okay, this is Ry. And the inner radius of revolution, or the smaller radius of revolution, this is the distance from the axis of revolution to the nearer or the inner boundary of the region. This means Ry. Okay. And we measure the radius of revolution at each position y. On the closed interval from C to D. Where is CD? Where is CD? See here, but D, you need to find D by to find the height of this point. What is the height of this point? Now we will define C, D, the outer radius of revolution and the inner radius of revolution to have a definite integral to find the volume of the solid. And we will define them. But C is 0 of course. C here is 0. And to define it, we need to find the height of this point. How to find the height of this point? We need to solve an equation. You can see the equation y is the square root of x. That means x is y squared. Of course, with the condition y here is greater than 0. And here x equals to y squared. And here x equal to 4. And you want to find the y coordinate of this point. That you need to find the y coordinate of the intersection point. So we need to solve the equation y squared equal to 4. And from y squared equal to 4, we obtain two roots. The first one is 2 and the second one is minus 2. But we just accept y is 2 because you can see the condition here. Y is greater than 0. And this is denied. Okay, so d here, of course, it is 2 pi. And now we measure ry. You can see ry here. This is a horizontal line. And the line of a horizontal line segment is x right minus x left. The x right here is 5 and the x left here. You can see y squared. So the length here is 5 minus y squared. Okay, and the square of the formula. And now we compute the inner radius of revolution. With the inner radius of revolution, this is the pink segment here. It is also a horizontal line segment, and its length is also, we also use the formula x right minus x left. X right here is 5, and x left here is 4. So we have 5 minus 4 squared dy. And you can use your calculator to find the answer here. Please use your calculator to find the answer here, okay? And we finish this example. In general, you can see the formula in the case the region is revolving about a line parallel with the y-axis. Look at the first picture. You can see a region which is bounded by the curve YEC, YED, XEL, and XEFY. By revolving our region about the line XEL, we are obtaining a solid of revolution. Our solid of revolution is totally solid mass. When we cut perpendicular to the axis of revolution, we will have a cross section which is a round shape. So we use this method. But our axis of revolution here is parallel to the y-axis. So the formula here is the definite integral from c to d pi r squared dy. Look at it. The differential here is dy. And r here is also the like the case when we cut perpendicular to the x-axis. Is also the radius of the disk, the radius of the disk, the radius of the cross section. But the radius of the cross section here is dependent on y, not on x, okay? And similarly, here is the formula for the washer method when the axis of revolution is parallel to the y-axis. I'm sorry, I forgot here. This is x-axis, and this is the y-axis, okay? 0, x, y here. And you can see a region which is bounded by the curve YEC, YED, XEFY, and XEGY. By revolving this region about the line XEL, we obtain a solid of revolution, but which is partially hollow inside. So when we cut perpendicular to the axis of revolution, we will obtain a cross section which looks like washer. So we need to use the washer method. But the axis of revolution here is parallel to the y-axis. So you can see the formula to find the volume of this solid of revolution. It's like this. The definite integral from c to d of pi r squared y minus small r squared y dy, where the big R squared y here. Sorry, the big R here is the outer radius of revolution, yet it is the distance from the axis of revolution to the outer boundary or the farther boundary of the region. And the smaller here is the inter or the smaller radius of revolution. You can see a pink segment here. This is the radius of the axis of revolution to the inner or the nearer boundary of the region. Okay, and they are all dependent on y, not on x, because the axis of revolution here is parallel to the y-axis. Our video is stopped here. If you have any question, please post your question on the Zello group. I will answer for you. Thank you for listening.